This is MATD 1544 and Unit 11. I'm not going to discuss the polynomials in details this morning, or in detail this morning. It is in the book. It explains what a polynomial is. That is like pre-knowledge for us. But remember that the exponents should be integers. And the important things for us in this unit about the pre-knowledge is, do you know what the leading coefficient is, the leading term, and so on. Now remember, the degree of the polynomial is the term containing the highest exponent, so the bigger power. And the leading coefficient is the coefficient of that term. So here 10, x10 is the highest power, and it has 2/3 in front, so that will be the leading coefficient. Because it's the leading term that takes over at infinity. So that is why that is so important. Standard form just means that it is arranged, that you've arranged either ascending or descending. Alright, so the end behavior, as I said, is determined by that leading term and the leading coefficient. So that is important to us. Okay, and that we must know. Then we said that if you have uneven powers, then you will have one arm down and one arm up in your polynomials if you draw the graph. So when it's a positive leading coefficient, it will be right arm up. So at infinity, the right arm will go up. And at negative infinity, the left arm will go down. That's for uneven powers, power 3, 5, etc. When we have even powers, we will have both arms up or both arms down, like the parabola that we used to. There's the parabola. And the higher the power, the more it will bend towards the y-axis because it is stretching now. Okay, so at infinity, I don't know who that is, but please put off your mic. Alright, so when we go to infinity, we go to positive infinity. When we go to negative infinity on the x now, we go to positive infinity on the y. Okay, right, there's the uneven powers that we just talked about. Okay, and then the number of turning points we have determine the type. So there's only one turning point, it will be quadratic, so you add 1. If there's 2 turning points, it will be cubic. If there's 3 turning points, it will be quadric. And if there's 1, 2, 3, 4 turning points, it will be quintic, in other words, power 5. Okay, you need to know this. This is a summary of the end behavior. And because you need to give us the end behavior in every single problem. Then we have discussed the two types, type 1 and type 2. So we said that if you have type 1, which is this one, then it means that there is x in every single term. In other words, the constant is 0. The constant term is 0. When we have that, we take out the common factor. We take out the common factor first, and then we factorize. Then we find the x-intercepts. The y-intercept will, of course, be 0, but we must still find that. And then we do the end behavior, and then we do the number line as we did last semester. And everything must correspond now. When we draw the graph, it must correspond with that table. Here we have a power 4 that we have done in class also. So even power, but it's type 1 because it's a polynomial. It's type 1. And that means that we factorize first, taking out the common factor, factorize everything, find the x-intercepts, making y 0, find the y-intercept, making x 0. Because this is a leading term of power 4, it means that both arms, it's even, and that means both arms up because it's positive. So end behavior up, end behavior on the negative side up. So you can also write this with a limit. Then you do the number line, and because I've warned so many times, be very careful not to always just decide it's going to be positive, negative, because here you can clearly see it's positive, negative, positive, positive. So when we draw the graph, it's positive, negative, positive, touching the x-axis, and turn to positive again. Okay, when we get to type 2 or type B, then we have a constant term. So this is now type B or type 2. Okay, that is when we have a constant term. Now, when we have a constant term, it means we must first find one root. We need to find a root. Any value for x that will make the whole expression 0. Now, if you may use a calculator, I would advise you to use the table mode to do this, like I've taught in class. So that makes it a lot easier. So the first thing is to find the value that will give us 0, and then we must then understand that x minus 2 will be then a factor, a linear factor of the polynomial. We need now, because this is power 3, we now need to find the quadratic factor. That we can do by long division, like we've done in the first semester, or by using synthetic division, or by just making use of inspection. Now, when we do inspection, we write our linear factor, which is x minus 2, right? And then we balance the equation, because this must be equal to p. It must be equal to p, because it's factors. So then we know by inspection that the first one here times the first one here must give the first one there. So that's why this should be x squared. And the last one here times the last one here should give the last one there. So minus 2 times minus 8 to give me my positive 16. And now I have minus 4x squared here. So the terms that will give x squared must group together to give minus 4. So this gives minus 2, but I must have minus 4. So that one and that one must give me the other minus 2. Therefore, this should be minus 2x. So that that one and that one can give me the other minus 2 I short, so that the 2 together can give me my minus 4x squared. And clearly you can see we get exactly the same quadratic factor. Now we can factorize everything into linear factors if possible. If this is not possible, irrational or so on, we will do the formula to find the x-intercepts, because the next step will be to find the x-intercepts now. And remember then the y-intercept, our end behavior, this is power 3. There's a positive in front, so right arm up, left arm down. So right arm up meaning positive there, left arm down meaning negative there. And then the number line, and then draw the graph. We're not going to do stationary points in this year because of the COVID. We have reduced the work a little bit. Okay, so once again, if we look at example 1194, we have a constant value there, making a type B. This is a type 2. But this is a power 4, and it's a positive power 4. So therefore, it should be both arms up at my end behavior. That I know already, and I will look forward to do it like that. So that will help me when so that everything can make sense when I get to the point of drawing the sketch. So again, find a value that will give 0. and then the linear factor. But remember, this is power 4 now. So when I reduce it now, it will be giving me power 3. Okay, so once I've done that, and I know x minus 1 is a linear factor, this is a cubic factor, but I need to come down to all the linear factors. So now I take that cubic factor, and I need to reduce that. And then that means I must find another x that will give me 0, not the same one I had before, because I already used it for the first linear factor. I need another x to give me a second linear factor. Now here we saw that minus 1 is giving me 0, so therefore x plus 1 is going to give me the other linear factor. And then again, long division, synthetic division, inspection, find the quadratic factor, factorize everything, and then find the x-intercepts, find the y-intercept, that will be the 6. I think there's a little mistake there. If it's 6 there, oh sorry, I need to look at the top one, sorry, that is correct. I remember that's the top one, so it's minus 6, that was the cubic factor. P is negative 6 there, so the y-intercept will be negative 6, okay. And then the end behavior, as we said, both arms up because it's even. So when x approaches infinity, it will be positive infinity for f or p, it should be p there. And if x approaches negative infinity, p will approach infinity. Do the number line, put your x-intercepts on top, and check the different regions like we've done last semester to find out whether it's positive or negative, meaning whether the graph is above the x-axis or below the x-axis. And then this should agree with your sketch. If you say positive there, it must be above. If you say going through 0 there, it means it must go through the x-axis. If it's negative there, it should be negative there. Going through the y-intercept, at minus 1 it should be at 0 again, it is. Then it should be positive, it is. Then it should go through minus 2, it must be 0 again, there it is. It should be negative, it is. It goes through minus 3 here, and it then bends up to be positive, both arms up, because of the even power 4. It's an even function. About the, I always get questions about the height here. That doesn't make, it doesn't, it's not a problem, that's what I want to say for now. When we do the stationary points, then of course we determine the exact point, the exact coordinates. But if you draw the sketch, you don't have to worry about it. As long as you show it's positive there, it's negative there, etc., then it will be fine. Okay, so a lot of marks here. That is how we sketch these graphs, the polynomials, and as I say, it is really important work for us for next year. Let us look at this together. Now 11, 10, 1. So here we've got a polynomial. All the powers have positive exponents. This one is arranged, giving me the highest power 3. So the leading term is x to the 3, and the leading coefficient is positive 1, which is positive. So I already know that I must have the right arm up and the left arm down. So I have that in my mind already. So now what I do, I go to my calculator and do the table mode and find an x value that will give me 0. Alright? So if we do, in school they taught you to do 1, to do minus 1, to do 2, to do minus 2. That is not a problem. If you do not have the calculator, you're welcome to do that. But It is just, if you may use your calculator, just makes sense to put the equation in, and because then you can see, and I like to use steps of 0.5 at least. The cashiers have a memory problem, the sharps don't have, so you must now restrict your begin and end values just to make sure, because it's like zooming in. So if you have steps of 0.5, you zoom in a bit more than when you would have had steps of 1. So it just makes it a bit better. And remember that if there's a 1 there and an 8 here, 8 over 1, we always take C over A, or D over A. If that's A, B, C, D, D over the coefficient there, 8 over 1, this gives us 8. Then we know one of the factors of 8 should give me 0. So 1, minus 1, 2, 4, one of them should be giving me 0. So I can try that and see what is going on. Let's see what happens if I do P of 1 here. Okay, so this gives me 1 minus 5, it's minus 4, plus 2, it's minus 2, plus 8, no, it's not giving me 0. Let's see if I do negative 1. So this gives negative 1, minus 5, and then 2 times negative 1 will be negative 2 plus 8. Okay, so this gives me negative 6, negative 8 plus 8. That does give me 0. My problem is just that this can be time consuming if it's not, if you're not accurate, or your guess is not good, and then it just makes sense to use the table mode. But okay. Remember that you can use the constant over the leading coefficient, and one of those factors should give you 0, so then you can narrow them down. So okay, so if P minus 1 is 0, then P plus 1 should be now a factor, and I need to show that to everybody. So P plus 1 is now a factor. And it's a linear factor. Okay, so this is a linear factor. Okay, so now I can go ahead and do long division, synthetic division, or inspection. I'm going to do the inspection, so I'm going to say P should now be equal to this. Sorry, that should be X plus 1, not P plus 1. I don't know why I wrote now P plus 1 here. P minus 1 gives 0, but X plus 1 is the factor. Okay, so X plus 1 is now the factor. So X plus 1 over here. And then inspection. First times first should give first. Last times last must give last. This gives 1x squared, but I need negative 5. So this should be minus 6. So that those two, together with those two, will give me the negative 5. So this is plus 1. I'm sorry for that. This is plus 1. And that is minus 6. That gives me then my minus 5. Okay, so now I need to factorize the whole thing. So x plus 1, x minus 2, x minus 4. Okay, there I have factorized the polynomial now. Alright, so now I can find my x-intercepts. Let's just go here for space. So now I can find my x-intercepts. So x is negative 1, or 2, or 4. Okay, and then my y-intercept is my constant value, so that's 8. So y is 8. I just want to make this 2 a little bit better that we can see it clearly there. Okay, now I've got the x-intercepts, I've got my y-intercept. Alright, let's look at the end behavior here. So the end behavior, okay, now this is as we said, this is a positive leading coefficient and it's uneven, so right arm up and left arm down. Remember, you must give for us the end behavior. So you can write it as if x approaches infinity. Remember, that's now p. P will also approach infinity. So the right arm will go up, in other words. And if x approaches negative infinity, the left arm will go down. So p of x will approach negative infinity. Okay. So that is my end behavior. Now I can just do my little number line, and then we can draw the sketch. So let us just see now here. We said x can be -1. Yes, x can be -1 included. I think I just want to have a color that's a bit more clear. Okay, x can be 2. X can be 2. And x can be 4. X can be 4. Okay, so check now. If I do 5, what will happen there? And then I see it's positive. Then check what is happening there, check what is happening there, check what is happening there. Be careful not to always just think positive, negative. Make sure. And now if you had your calculator on the table mode, you would have just be able to look at the values in between there and you would have seen if it's positive or negative. Another reason why I say it's nice to have the table mode on your calculator done. Alright, now the last step is just now, we need to draw this graph now, and it must make sense with the end behavior and also with my number line. If my number line says positive, it should be positive there, etc. Okay, so here I have my -1, there I have my 2, so there I have my 4, and my y-intercept is 8 there at the top. That's the y-intercept. It's not the turning point, it's the y-intercept. So the graph will go down there and go up there, and of course will go down here. Alright, so now I just check. It's positive there, it's positive there. It's negative here, it's negative here. It's positive here, it's positive here. It's negative here, it's negative there. Okay, and there we have drawn the sketch graph of this specific polynomial. So if we just look at the marks here, sometimes we will make it half marks, but just so that you can see. So you need to show us the value that will give us 0, the linear factor, the quadratic factors. Sometimes we will give 1 here, sometimes 2, but you know, remember you're on university level, so to factorize that is not really something. And then the x-intercepts, the y-intercept, the end behavior, and we give about 3 marks always here for the graph. So you cannot just draw the graph. You will only get 3 out of 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So that will give you now oh yeah, sorry, and also 2 marks for the number line that I forgot there. So sometimes we make this half marks and then 14 or whatever, 7 marks in total or so. Okay, so that concludes now how we can draw the polynomial, the sketch graph of the polynomial.